class. I'm C105 class. As promised, I I am creating this YouTube video so we can go over this percent composition question, right? I told you it's a more complicated question. It's definitely ETQ. Keep that in mind. Exam type question. All right. So please keep that in mind. Um, And again, the reason I'm doing this is because I think this problem requires a little bit of thinking on your part where you're watching the video, you can pause for a little bit and then think about what's happening. And that is why, and then definitely so that I do not fall behind covering all the concepts in C105 as well as those two rationale. All right, so remember, this is a percent composition problem or mass percent problem, right? The difference between the problem that we worked on uh, versus this is in this problem, they have given us the mixture, right? Mixture of MgS and NaCl. So you have MgS and NaCl. And think about mixture, right? Is we do not know for example, it's not like they are in 1 mole and 1 mole mix, right? That's not the mixture. The only thing they have told us is in that mixture, the mass percent of sodium is 5.8%. Right? That's the only information that they've given us. So it could have maybe like it could be 1.5 moles NaCl that has combined with, I don't know, 5.8 moles MgS to make the mixture, right? Or it could be maybe NaCl is in excess. We do not know. And that's what we are trying to figure out. The only thing that we know is in the whole mixture that contains MgS, magnesium sulfide, and sodium chloride, the mass percent of sodium is Na. All right. So first thing what I'm going to do is like remember similar to the our other mass percent problem. I'm just going to go ahead and figure out the molar mass of all the atoms that are there. All right. So write it down. I mean magnesium. If you look at the periodic table, it's 24.3 grams per mole. Right. My sulfur is 32.1 grams per mole. And then you have sodium chloride. Sodium is 23.0 grams per mole. Again, where I'm just taking one digit after decimal, keep that in mind. And then finally, your chlorine is 35.5 grams per mole. All right. First thing I'm going to do, then the next step, what I'm going to do is I'm going to calculate the mass percent of sodium in sodium chloride. All right, my next step. So let's call this step number 1. Step number 2 is mass percent, and I'll let you know why am I doing that. All right, of sodium in NaCl. All right, similar to how we've been doing, right? So to find the mass percent of Na in NaCl, again, all I do is what is the molar mass of Na, right? Divided by molar mass of NaCl times 100%. Again, the formula did say something like mass of 1 mole of Na, right? In the numerator instead of this, right? And mass of 1 mole of NaCl instead of that. But again, keep in mind that's the same thing, right? Mathematically speaking, it'll end up being the same thing, and that is why I wrote that. All right. So now all I do is plug in my values. Molar mass of Na is 23 divided by NaCl is, if you add these two numbers, Na and Cl, end up with 58.5 times 100. That gives me 39.3%. Right? Now, third step is where the students find a little bit challenging to understand what's happening, right? What I'm doing in my third step, right? I'm going to use in my third step, I'm going to use this 5.8%, which is the percentage of Na in the mixture. And then I'm going to use my this 39.3%, which is the mass percent of Na in NaCl, all right, to figure out the mass percent of NaCl in the mixture. Mass percent of NaCl in the mixture. That's what I'm trying to figure out. All right. Now to do that, all I do is I take my mass percent of Na in the mixture divided by the mass percent of sodium in NaCl times 100 will give me 14.76%. Now this is where even I had to sit down as to think about how this formula works. All right. Now if you think about this, right, let's think mass percent of NaCl in the mixture is basically mass of NaCl or molar mass of NaCl divided by the molar mass of the whole mixture, right? Now let's break it down, right? For example, if you have 5.8%, which is the mass of Na. So again, this is just conceptual understanding, right? Divided by mass of mixture, the whole thing. That's my 5.8%, right? That is being divided by my 39.3% is mass of Na in mass of NaCl, right? Not the mixture, just in NaCl, right? And then we multiply that by 100, isn't it? Now, watch what happens. So if you do the mathematically, right, what's going to happen is the mass of Na cancels out with mass of Na. This mass of NaCl ends up going to the numerator, and this will end up looking something like this. Mass of NaCl divided by mass of mixture times 100. And wouldn't that be the mass percent of NaCl in the mixture? And that's why this formula works. All right. And I hope you understand this conceptually so you are able to understand, oh, this is why I did this. That's why I took the mass percent of Na in the mixture, divide that by the mass percent of Na in NaCl, right? So mass percent of Na in the mixture, mass percent of Na in the NaCl will give you the mass percent of NaCl in the mixture, which ends up being 14.76%. All right. All right. Now, am I done? No, because our goal is to find the mass percent of magnesium, sulfur, and chlorine. But then now this percentage will help us figure it out. Right. So this is the mass percent of NaCl in the mixture. If I subtract 100 minus 14.76%, that will give me my fourth step, right? Mass percent of MgS in the mixture. So 100 minus 14.76%, and that will be end up being 85.24%. Battle almost done. We're almost there. All right. So I'm going to take these two numbers now, right? This 85.24% and 14.76% to figure out the mass percent of Mg, sulfur, and chlorine. All right. So I'm going to open a new page. All right. My last step is basically step number 5. To find my mass percent of each element. right? So let's start with percent of magnesium, right? Magnesium's molar mass is 24.3 grams per mole, right? In magnesium sulfide. Remember, we figured out the, so if you go back to our earlier slide, we figured out the mass percent of MgS in the mixture, right? And that is why I'm going to figure out the this third. This is create a new one. Where did my 71 and 72 screen go? Okay, I'm just going to create a new one. Shoot. Right. So our goal again, mass percent of each element. That's our goal. Right. The first one is to figure out the percent of magnesium. All right. All I do is I take the molar mass of magnesium. Now what's this? I'm going to divide that by the molar mass of magnesium sulfide, because we do have the percent mass of MgS in the mixture as it's 85.24 calculated, right? So if you add up it, magnesium and sulfur, you end up with 56.4 grams are in 1 mole, right? And I take the molar mass of MgS times our percentage of MgCl in the mixture, and that will give me 36.7. It takes some time, right, to kind of sit and think about it, right? So remember, this is the mass of Mg. This is the mass of MgS, or molar mass to be explicit, right? And then this is the mass percentage of MgS in the mixture. And that's why we're able to figure out the percent Mg here. All right. Next thing, same thing, right? Per percent sulfur. All we do is take this molar mass of sulfur, divide that by the molar mass of MgS, and then multiply that by our 85.24%. And that will give me 48.5%. All right. For the chlorine, what you can do is you can add all the percentage up and then subtract 100%, right? Or if you want to go this on the route, mass of 1 mole of chlorine, divide that by the molar mass of sodium chloride, or mass of 1 mole of sodium chloride, times 14.76%. Be careful with this, because remember, this percentage was the mass percent of NaCl in the mixture. That's why I'm going to use this, right? And sodium was 5.8%. That means if you add all these numbers up, 36.7, 48.5, 8.9, and 5.8, it'll give you something very, very close to 100%. And that's what I mean by for percent Cl, right? You don't have to really do this. If you wanted to add this number, and this number up and separate that from 100%, that should give you the 8.9%. All right. Now again, like I said, this question is challenging. It's not easy. So take your time, sit down. All right. I think there are some problems in the PLTL workbook that are similar to this. All right. That will help you uh, help with more practice. All right. Take your time and then go through what did I do in step number 1, step number 2, step number 3, step number 4, and then finally step number 5 to find the percent of magnesium, sulfur, and chlorine, and so on. Right, so I'm gonna stop here. Good luck with this question, and hopefully when in exam, when this question shows up, you're able to answer this.